In this lecture, we take the example of DUIS rule number 2. The question is, if y is equal to integration under the limit 0 to x of f of t sine a times of x minus t with respect to t, then so that d2y dx square plus a square y is equal to a f of x. So we have given that y is equal to integration under the limit 0 to x f of t sine a times of x minus t with respect to t. So let us give it equation number 1. Then now then we have to prove this result. Now using DUIS rule or Leibniz rule, we have dy dx, which is equal to, what is the Leibniz rule or DUIS rule number 2? This is nothing but di d alpha, which is equal to integration of a to b f of x alpha dx plus f of b alpha derivative of b with respect to alpha minus f of a alpha derivative of lower limit a with respect to alpha. Now here the lower limit is 0, upper limit is x, a to b, 0 to x. F of x alpha is f of t sine a into x minus t, right? So now if we use this formula, the first thing is derivative of, now here t is the independent variable and x is parameter over here. So dy dx, which is equal to integration under the limit 0 to x, derivative of, now there is a derivative of this. So derivative of f of t sine a times of x minus t with respect to, because here t is independent variable, so dx with respect to t over here plus the functional value of f of t sine a x minus t at upper limit. So we have to put t equal to x. So this will become f of t, in place of ft we have to write down x sine a sine a into x minus t is again x, so x minus x, derivative of upper limit, which is x with respect to x, minus f of 0, because lower limit is 0, so f of 0 sine a x minus 0 and derivative of lower limit and derivative of lower limit. So this is what? This is the DUIS rule 2 or Leibniz rule. Again, let me again explain it. This total term is f of x alpha. Dy dx, we want to find out, actually we want to apply DUIS rule twice because the order of the differential equation is 2. So let us first apply the first DUIS rule number 2, dy dx, which is equal to integration under the limit 0 to x, derivative of f of t, this total term f of t sine a times of x minus t with respect to x dt plus functional value of this function at t equal to upper limit x. So we have to just replace this t by x. So f of x sine a x minus x into derivative of upper limit with respect to x. So this is d dx of x minus the functional value of f of t sine a into x minus t at lower limit t equal to 0. So just put t equal to 0 over here. F of 0 sine a x minus 0 and derivative of lower limit which is 0 with respect to x. Let us again simplify it. Here f of t is constant, so we can take outside with respect to x. Now derivative of sine a x minus t with respect to x. We want to find this derivative plus sine x minus x. Sine x minus x is sine 0 and we know that sine 0 is 0. So we have written 0 over here, and again here derivative of 0 with respect to x is 0. So this term is also become 0. So dy dx is equal to integration under the limit 0 to x f of t derivative of sine a x minus t is cosine a times of x minus t. Again derivative of a times of x minus t with respect to x is nothing but a, and this term is 0 and this is also 0. So we don't have any other remaining terms. Let us go ahead. Again applying DUIS rule. So what we have now, this one f of t a cos x minus t into a, this is what? This is our f of x alpha. So we apply the same formula over here. Same formula we will apply. So what will happen? d2y dx square integration under the limit 0 to x of a f of t cos a x minus t. This is what? This is f of x alpha over here. Plus the functional value of this function at t is equal to x. So let us just put t equal to x. So a f of x into cos a x minus x derivative of upper limit which is x minus a times of f of 0. We have to put the upper limit x t equal to 0. So a f of t means f of 0 cos of a x minus 0 derivative of 0 with respect to x. This is lower limit. Let us again substitute all this, simplify this one. A times of f of t we can take outside. Derivative of cosine a times of x minus t with respect to x with respect to dt whole integration of this thing with respect to t plus f of x cos x minus x is 0. So cos 0 is 1 and derivative of x with respect to x is also 1 minus a f of 0, and this is what? Derivative of 0 is 0. So that this part is ultimately 0. Now let us write down d2y dx square, which is equal to the derivative of cosine a times of x minus t with respect to x is minus of sine a x minus t. Again derivative of ax with respect to x is a, and under the limit 0 to x with respect to t plus it is a times of f of x. Now this a and this a we can take outside the integration. So we have minus a square integration of under the limit 0 to x f of t sine a times of x minus t dt plus a times of f of x. Now this is nothing but y. So this can be written as minus a square y plus a f of x, which gives us d2y dx square if we transpose this to right and left hand side plus a square y, which is equal to a times of f of x, which is the desired result. Hence proved. Thank you.